A very good afternoon to all of you children. We are studying about mirrors in the light chapter. Mirrors are such an attractive thing. आप लोगों की मन में तो mirror is something that is a part of your life next to you all the time. Because you like to see yourself into the mirrors and admire. That's a basic human nature. That's perfectly fine. Everybody has this flair of admiring, and it is a very good sign of confidence that you can admire yourself. That is how you build confidence in you. And we have studied. अभी तक तो आपको यही मालूम था सर. There is one mirror that we have in our homes, and that is a plain mirror. We now know that there are spherical mirrors also. So mirrors can be either plain mirrors, or the mirrors can be spherical mirrors. And spherical mirrors can be either concave or convex, which we have already done. You have drawn beautiful ray diagrams. All of you have memorized that which mirror forms what kind of an image. You very well know how to obtain an image if I give you two incident rays. All those things we have already discussed. Right? And now, yesterday I discussed with you the application of mirror formula. Because we are going to enter the topic of doing numericals. Right? So, for doing numericals, you have to use the formula. But here, in the numericals of this chapter, the concept of putting a positive sign or a negative sign. कहाँ पर पॉजिटिव साइन लगाना है, कहाँ पर नेगेटिव साइन लगाना है, कौन से डिस्टेंस को पॉजिटिव लेना है, कौन से डिस्टेंस को नेगेटिव लेना है, that is very, very, very important. So you have to solve the numericals very, very methodically. For both the mirrors, the concave mirror, which is whose polished area is the outer area, as well as the convex mirror, whose polished area is the inner curved area. For both the mirrors, we have a formula which we call as mirror formula. Mirror formula is an equation which coordinates the three basic fundamental distances of ray diagrams, that is the focal length, the object distance, and the image distance. Now these are the symbols used for representing focal length, the object distance, the image distance. Right? But this formula cannot be applied for doing numericals unless and until you are aware of Cartesian sign conventions. There are certain rules laid down for you people to use this formula to solve your numericals. Today we are going to do those rules in front of you. And believe me, they are very, very simple, very easy. All of you are quite good in mathematics. So this topic is related to mathematics. Right? So you already have a concept of number line, and here also we are going to use that concept. So let's begin. We'll first do the Cartesian sign conventions by taking an example of a concave mirror, and then we apply it to the convex mirror. I'll do it for the concave mirror, and you will apply it to the convex mirror along with me, so that you can practice these rules well. Right? So let's begin. The Cartesian sign conventions, rules for a concave mirror. A concave mirror is a spherical mirror whose reflecting surface is the inner curved surface. This is the reflecting surface, and this is the polished surface. All of you are very well aware about these facts. You draw beautiful diagrams. Very, very precisely, I have already seen with you. Right? Now, if you draw this diagram with the compass, it is very easy to locate the pole. If this is the center of curvature, we are taking it for the sake of doing the example. Center of curvature, the distance, this point where the principal axis touches the mirror, this is pole, which is supposed to be the geometrical center of the mirror. Pole, denoted by capital P. This distance between the center of curvature and the pole, this is known as the radius of curvature, denoted by the letter R. This distance. This is R. Suppose you have taken radius of curvature as 10 centimeters, then we will mark the focus at 5 centimeters. This is the focus. All these are points which are very clear to you already. Right? Now, we are going to take an example of the position of object when we take the object beyond the center of curvature. The height of the object is labeled as AB. The position is labeled as O. And all of you know, when you take the object beyond C, we get an image between C and F. Principal axis के नीचे उल्टी image, real or virtual? Obviously real. It's a real image because it's below its principal axis. Now, this image, the height will be labeled as A dash, B dash, and the position is labeled as I. Right? So, if you take this example, for learning the Cartesian sign conventions rules, it will be easy for you to apply these rules to any ray diagram, any mirror, whether it is plane mirror, convex mirror, or concave. Right? Now, first of all, let us see that what does the mirror formula talk about? It talks about focal length, it talks about object distance, and it talks about image distance. एक बात अच्छे से ध्यान रखनी है कि फोकल लेंथ, ऑब्जेक्ट डिस्टेंस, इमेज डिस्टेंस को डिनोट करने वाले जो लेटर्स हैं, दे आर वेरिएबल्स. तो इनके साथ हमें कभी कोई साइन नहीं लगाना. वी आर नॉट गोइंग टू राइट माइनस एफ और प्लस एफ यू और माइनस बी. नेवर. The signs are to be put with the constants. Focal length is 10 centimeters. So वो जो 10 centimeter है, वो प्लस या माइनस हो. Right? Let's practice to be made clear further also. This is focal length. Now, where do you see the focal length in this diagram? What is the focal length? क्या ये focal length है? वो तो focus है. Focus और focal length एक ही बात होती है? Not at all. Focus is a point lying on the principal axis through which all the parallel incident rays after reflection pass. ये एक पॉइंट है. हम बात कर रहे हैं स्मॉल एफ, फोकल लेंथ. सो फोकल लेंथ इज द डिस्टेंस बिटवीन द पोल एंड द फोकस. दिस इज द फर्स्ट रूल ऑफ Cartesian sign conventions, that all the distances are measured from the pole. You can see I am making the arrow like this. I am not making a geometrical double arrow distance. I am not showing you a distance. इसको आप PF बोलिए या FP बोलिए. That's not correct. All distances are measured from the pole means you have to call it PF. I cannot call it FP. Got it? So all distances are measured from pole. So focal length will be denoted as PF. Then comes object distance. The word itself is very clear. Object distance means the distance of the object from the pole. So here is the pole and here is your object. So this distance is the object distance, denoted by small e. And the third variable is image distance. Again, the word itself clearly implies what is image distance? It is the distance of the image from the pole. Right? So distance of the image from the pole Radius of curvature I have already denoted. So U is denoted as P, B, B is denoted as P, B dash, and R is denoted as P, C. P, C. It's a distance on the principal axis, not Priyanka Chopra. Okay? So focal length, object distance, image distance, and radius of curvature. All these distances are measured on the principal axis from the pole. Right? That is the first rule. तो अगर हम ऑब्जेक्ट डिस्टेंस को पढ़ेंगे तो हमेशा पी बी बोलेंगे, बी पी नहीं बोलेंगे. इमेज डिस्टेंस पढ़ेंगे तो पी बी डैश बोलेंगे, बी डैश पी नहीं बोलेंगे. This is what has to be clear. Okay? So this is the first Cartesian sign convention rule that all distances are measured from the pole. Right? Then comes the second rule. Before we do the second rule, let's also see what are these HI and HO. HI stands for height of the image. This height of the image, which is denoted as A dash, B dash. And HO is height of the object, which is denoted as AB. अब ऑब्जेक्ट की हाइट दी हुई है 5 सेंटीमीटर, प्लस 5 लेना है या माइनस 5 लेना है. That is what is going to be made very clear when we do the Cartesian sign conventions. एक बात हमने सीखी कि सारे डिस्टेंसेस जो हैं, फोकल लेंथ, ऑब्जेक्ट डिस्टेंस, इमेज डिस्टेंस एंड रेडियस ऑफ कर्वेचर, these are distances. They all are measured from pole. HI and HO, these are heights. हाइट किसी चीज की, प्रिंसिपल एक्सिस के ऊपर, प्रिंसिपल एक्सिस के नीचे. तो ये हाइट्स हैं. नाउ लेट्स डू द सेकंड रूल. और ध्यान से सुनना है और अच्छे से समझना है. व्हाट इज द सेकंड रूल? सेकंड रूल को हम दो तरह से समझ सकते हैं. इजी वे है द नंबर लाइन मेथड. नंबर लाइन मेथड में सेंटर में 0 होता है, राइट हैंड साइड में सब कुछ पॉजिटिव होता है, लेफ्ट हैंड साइड में सब कुछ नेगेटिव होता है. राइट? बिल्कुल वही कंसेप्ट यूज होगा यहाँ पर. The same concept will be used. This is the mirror, this is the pole. Whatever distance we measure on the left hand side of the mirror will be taken. Left hand side of the 0, left hand side of the mirror, all those distances which are measured on the left hand side of the mirror will be taken as negative. And all the distances which are measured on the right hand side of the pole of the mirror will be taken as positive. So easy, just like number line. Number line को छोटी कैसे करते हैं? Right hand side positive, left hand side negative. Right? Mirror left hand side जितने भी distances हैं सारे negative, right hand side जितने भी distances हैं सारे positive. There is a second interpretation of this. इसी रूल का एक और इंटरप्रिटेशन दीजिए कि अगर हमारा ये ऑब्जेक्ट है तो द इंसिडेंट रे टुवर्ड्स द मिरर विल कम फ्रॉम द ऑब्जेक्ट टुवर्ड्स द मिरर. सो इफ द इंसिडेंट रे इज गोइंग इन दिस डायरेक्शन एंड वी आर मेजरिंग ऑब्जेक्ट डिस्टेंस इन द ऑपोजिट डायरेक्शन, इंसिडेंट रे की डायरेक्शन ये है फ्रॉम लेफ्ट टू राइट, बट ऑब्जेक्ट डिस्टेंस इज टुवर्ड्स लेफ्ट, सो इट विल बी टेकन एज नेगेटिव. I hope it is clear to all of you. So अगर मैंने किसी क्वेश्चन में ये देखा कि मेरा ऑब्जेक्ट डिस्टेंस जो है ना वो 25 सेंटीमीटर है और वो मेरा कॉन्केव में है, राइट? तो वो रहा ऑब्जेक्ट ये U 25 सेंटीमीटर है. So 25 सेंटीमीटर प्लस 25 हो गया ना, माइनस 25 हो. Should I take it as positive or should I take it as negative? Look at this. whether it is plane mirror, concave mirror, or convex mirror. It is always mirror. Right? Please make a note of it. Then comes the focal length. In this case, this is the focal length. Again, you can see it is on the left hand side. So suppose I say that the focal length of this mirror is say 10 centimeters. Focal length, this distance is 10 centimeters. Now should I take it as positive or should I take it as negative? Obviously negative. Because the object is on the left hand. The focus is on the left hand side. This is the focus and this is the focal length. So focal length for a concave mirror will be -10. I am not writing a minus here. See, pay attention on this. I am not putting any minus sign with on the variable. I am putting it with the constant. ये चीज ध्यान रखने वाली है, right? Then comes the image distance. Image distance is B dash on the principal axis. So image distance is also on the left hand side. So suppose हमारा इस केस में image distance आ रहा है, say for example 15 centimeter. So here again it is going to be negative because the image is on the left hand side. Fine. Radius of curvature is PC. This is also on the left hand side. So we will call this also as negative. And if we say the focal length is 10 centimeter, so radius of curvature will be double of focal length. All of you know that R is twice of F. So if I have taken focal length 10 centimeter, even for an example, I should take a correct reading of R as 20 centimeter. So this also is going to be negative. So ये तो सब कुछ ही negative हो गया. See, the focal length is negative, object distance is negative, image distance is also negative, and the radius of curvature is also negative. So for a concave mirror, everything is negative. Is there anything which can be positive? See, focus is never going to shift. Focus for a concave mirror is always in front of the mirror. The object will always be kept in front of the mirror. तो वो भी negative रहेगा. Focal length भी negative रहेगा. Center of curvature is again fixed. Concave mirror का center पीछे हो जाएगा नहीं. तो क्या ऐसी कोई चीज है जो positive हो सकती है in case of a concave mirror, or everything is going to be negative all the time? No. एक केस ऐसा है जिसमें हमारा image distance, that is V, it can become positive. Can you think about that situation? कब आता है V? Behind the mirror. Image distance behind the mirror कब होता है? जब virtual image आती है. अगर image virtual आ गई, behind the mirror आ गई, तो फिर हम ऐसे नापेंगे image distance on the right hand side. This will be the image A dash B dash. So for a concave mirror, एक ऐसा केस है जिसमें image distance positive हो सकता है. And that is the case when we take the object between focus and the pole. Focus और pole के बीच में object रखते हैं, तब ऐसा possible है. Right? So I hope I made the second rule clear. The second rule says anything that we measure on the left hand side will be taken positive. किसके left hand side? Mirror के left hand side. And anything which is taken on the right hand side of the mirror will be taken as positive.